Math 100, lesson 10.5. We are going to multiply radicals again, a little different than what we were doing before. And we are going to rationalize denominators. Okay, let's start with just our multiplying. So if I have the square root of 7 times 3. Okay, so I've got a radical times not a radical. Well, you can't go inside to multiply, so this would just be 3 times the square root of 7. Okay, if I have the square root of 7 times the square root of 5, that's like one of those problems where we were multiplying. Well, I can go inside there, and that would be the square root of 35. Okay, so let's just make sure we keep that straight in our head. If I have the square root of 6 and I want to distribute it through my parentheses. Okay, if I want to distribute it through my parentheses. So I'm going to multiply square root of 6 times both of those. Okay, when you do that, square root of 6 times x, the x sits outside of square root of 6. You can't go inside because it's not a radical. You can multiply the square root of 6 times the square root of 10, and you get the square root of 60. We're still not done yet because that square root of 60, you need to simplify. Okay, anytime we're leaving answers that are in radical form, you need to make sure they are simplified. Just like fractions have to be simplified, so do radicals. This x on the square root of 6, can't do anything to simplify that. But I can simplify 60. I know that 60, is 4 times 15. So the square root of 4 is 2, and the 15 stays inside. So that would be my answer there. That's as simplified as I can get. Let's try a cube root. So the cube root of y. And let's distribute that through the parentheses here. All right, so we're multiplying the cube root of y through the parentheses. Okay. Since it is a cube root times a cube root, we would get the cube root of y cubed. We multiply the y times the y squared. Minus, again, we have a cube root times a cube root, so we can multiply inside, and that would be 7y inside. Now this cube root of y cubed, I can actually do that, and I get y. And then minus, you cannot do the cube root of 7y. So that would be our solution. All right, so this one looks like a really big problem. It's just a big FOIL problem. I have a binomial times a binomial. So we're going to multiply 6 on the square root of 5 times both of those. Then we're going to multiply 3 on the square root of 2 times both of those. We're just doing FOIL here. Okay, so 6 on the square root of 5 times 2 on the square root of 5 would be 12 on the square root of 25. 6 on the square root of 5 times negative 4 on the square root of 2 would be negative 24 on the square root of 10. All right, now we're moving on to the 3 on the square root of 2. 3 on the square root of 2 times 2 on the square root of 5 would be plus 6 on the square root of 10. 3 on the square root of 2 times negative 4 on the square root of 2 would be negative 12 on the square root of 4. All right, now we simplify anything that can be simplified. Okay? I know that the square root of 25 is 5. These two in the middle are like terms. They both have a square root of 10, so I'm going to go ahead and do negative 24 plus 6 gives me negative 18 on the square root of 10. And I know that the square root of 4 is 2. So 12 times 5. We bring down this 18 on the square root of 10, and then negative 12 times 2. Now we can combine that 60 and the 24. So it says 60 minus 24, and we would get 36 minus 18 on the square root of 10. Nothing else I can do there. That 18 is connected to that square root of 10. So this would be our final answer there. All right, let's do another one of those. Very similar. Now some of you may recognize that's a difference of squares. Awesome. I'm going to do the FOIL. Do all my distributing just so I can show everyone. So I've got the square root of 5 times the square root of 5 gives me square root of 25. Okay. Then I've got the square root of 5 times negative square root of 2 would give me negative square root of 10. Now I'm going to multiply the square root of 2 times square root of 5. I get positive square root of 10. And then I multiply positive square root of 2 times negative square root of 2. I get negative square root of 4. Well, I know that the square root of 25 is 5. These two in the middle are like terms. One's a minus and one's a plus, so it gives me 0. And then I've got minus square root of 4 is 2. So I end up with a number that looks like a much better answer on this one. I get 3. All right, now this particular problem has a name. When that happens, it looks like difference of squares up there. That's called a conjugate. And you're going to see that word again. I'm going to say it again. You're going to hear it. You're going to see it in directions sometimes. All right, so here's what it is. It's a radical expression that involves the sum and difference of the same two terms. So if I have the two terms square root of 5 and square root of 2, those are my two terms, right? The same two terms. I've got square root of 5 and square root of 2. Well, two expressions that involve the sum and the difference of those would be square root of 5 plus the square root of 2 and square root of 5 minus the square root of 2. These are considered conjugates of each other. Okay, now the reason that's important, we'll find that out in just a minute, why it's so important. For the moment, let's go on to rationalize the denominator. Now, when I rationalize the denominator, problems get a little bit bigger. That's when we're going to need that conjugate. So we're going to start small, work our way up to the ones where we need the conjugate. All right, now the reason we rationalize the denominator is you never, ever, ever are allowed to leave a radical in the denominator. A square root, a cube root, a fourth root, any kind of radical in the denominator. You can't do that. Can't leave it there. Oops. Okay, so this is why we rationalize the denominator. We rationalize it because we're never allowed to leave a radical in the denominator. All right, so we are going to rationalize 1 over the square root of 3. Now, there is clearly a radical in the denominator, which I just said you cannot have. So if you type this as an answer in My Math Lab, it's wrong. All right, because there's a radical in the denominator. So to get rid of that radical, we are going to multiply the numerator and the denominator by the square root of 3, that radical. Now think about that. Square root of 3 divided by square root of 3 actually has a value of 1. So we're not changing the value of what's written there. All right, so let's do that. 1 times the square root of 3. The 1 would stay on the outside. Don't really need to see it sitting there. And square root of 3 times square root of 3 is the square root of 9. So I end up with the square root of 3 in the numerator, and the square root of 9 is 3. So that would be a rationalized denominator there. Okay, let's say you had a problem that simplified all the way out to this, the cube root of 2/9. Again, you can't type that in My Math Lab as a final answer because we learned that there's a rule. That fraction is really this, the cube root of the numerator and the denominator. There is a radical in the denominator, and we can't leave that. Now, this time, rationalizing is not exactly the same as the last one. We are not multiplying by the cube root of 9. And I'm going to show you why. I'm going to do it and show you why this is wrong. Okay, here's why this is wrong. If I actually do this, I would end up with the cube root of 81 in the denominator. Well, guess what? You can't take the cube root of 81, so that didn't do me any good. That's why cube root of 9 times cube root of 9 over cube root of 9 is not going to be helpful. All right, so that's a no-go. What I need to be asking myself is, what do I multiply this by so that my answer is something I can take the cube root of? You can't take the cube root of 9. So what is something I can take the cube root of? I know I can take the cube root of 8, right? Okay, but 9 times something is not going to give me 8. I can take the cube root of 27. So there's my number. So if I say the cube root of, when I multiply 9 times this number, I want to get 27. So that has to be a 3. I know for some of you, you're like, what just happened? Okay, so we're multiplying the numerator and the denominator this time by the cube root of 3. All right, so my denominator, that gives me the cube root of 27. My numerator, I get the cube root of 6. Remember the goal here. Cannot simplify the cube root of 6, but the cube root of 27 is 3. Our goal was to get rid of the radical in the denominator, and now it's gone. All right, let's try another one. And go back to a square root. All right, so we're still rationalizing. Well, the first thing I'm going to do is split it up. Square root of the numerator, square root of the denominator. Now, the square root ones are the easy ones. Okay, those are the ones we like. We're going to multiply the numerator and denominator by the square root of whatever that denominator is right there, that square root of 7y. Square roots are the easy ones. All right, so now in my numerator, I get the square root of 14xy. In my denominator, I get the square root of 49y squared. Okay, that numerator can't simplify. The square root of 49 is 7. The square root of y squared is y. So that would be my answer. All right, let's do another one that is not a square root. Okay. Now we are going to multiply by something, but here's my goal. I want to get the fifth root of something I can take the fifth root of. All right? So 8 times whatever number I choose to put right here, and then I should be able to take the cube root of that multiplication. So 8 times 4. Well, there's a better one. I'm sorry, not 4. Not 4, not 4. We're taking the fifth root of. Let's do 2, because I can take the fifth root of 16. No, I can't. I'm going to write this a little differently, because I think if I show you a different way to write this one, it'll be a little more easy to understand. So right now, all I'm doing is I am going to rewrite 8 as 2 cubed. Because that's what 8 is. 8 is 2 cubed. I think this will be helpful for you to decide what are you multiplying by. Now remember our goal. We want to get the fifth root of something I can take the fifth root of. Well, if I have 2 to the 5th over here, the fifth root of 2 to the 5th is 2. Just like with the variables. So, in this radical right here, I have 2 cubed. If I multiply it by 2 squared, that will give me 2 to the 5th. All right, let's do this variables the same way. I have x squared here. I want it to be x to the 5th because I can take the fifth root of x to the 5th. So that means that I need to multiply by x cubed. So that when I multiply x squared times x cubed, I get x to the 5th. And then the last thing would be our y. My y right here, I want it to be y to the 5th. So I'm going to multiply y to the 4th times y so that I get y to the 5th. Now whatever we do to the denominator right here, whatever we choose to multiply down here, that's what you do it on the top and the bottom. Alright, so my numerator, this 6x, is going to sit out front of that radical. Now 2 squared is 4, so I'm going to go ahead and write that down. Alright, so my numerator, don't forget that that's a fifth root. Now I can take the fifth root of 2 to the 5th, it's 2. I can take the fifth root of x to the 5th, it's x, and the fifth root of y to the 5th is y. So that would be my solution. Now, if we type it in my math lab just like that, we're not quite finished. It's going to say, uh-oh, you're wrong. And you're going to be like, wait, why is that wrong? We did everything right. Well, look at this 6 and this 2. You can simplify that. This x and this x, we can simplify that. 2 goes into itself once. It goes into 6 3 times. X goes into itself once and once. So the answer we should type in my math lab is 3 on the fifth root of 4 x cubed y divided by, we've got a 1 times a y. This is the answer we should type in my math lab because it is simplified. It's going to take some practice. You're going to get it. Okay, and now I told you we would figure out why did we learn that whole conjugate thing? All right, here's why we learned conjugate. We have a radical in this denominator. To rationalize this radical, we are going to have to multiply by the conjugate of the denominator. Abbreviate there. So the conjugate of our denominator is 2 on the square root of 3 minus 3. Whatever you do to the bottom, you have to do to the top. All right, so now we multiply. So I'm going to distribute this 18 times 2 on the square root of 3 minus 3. Okay, I'm going to distribute that. And in my denominator here, I'm going to go ahead and multiply. I get 4 on the square root of 9 minus 6 on the square root of 3 plus 6 on the square root of 3 minus 9. Okay, I did my FOIL. Right, in my numerator, I'm going to distribute that 18. I get 36 on the square root of 3 minus 54. And then in the denominator, these two are like terms. I know that the square root of 9 is 3, so that says 4 times 3, which is 12, minus this 9 that is still sitting here. So I get 36 on the square root of 3 minus 54 all over 3. Hopefully you're double checking yourself and making sure, hey, it's a fraction. Is it all the way simplified? You can factor out a 3 in the numerator. All right, so we're going to do that. We're going to factor out a 3 in the numerator. And that would leave me with 12 on the square root of 3 minus 18 divided by, we still have that 3 in the denominator. Now the reason I did that is 3 can simplify. And my solution is 12 on the square root of 3 minus 18. My math lab does expect you to give all of your answers simplified. All right, so that's why we would use the conjugate, and that's how we would use the conjugate. So please practice that, and make sure if you've got any questions, you let me know as soon as you have questions so that I can try to get those cleared up with you.